This chapter is going to guide you with recommendations and procedures for service technicians to follow when they encounter certain situations. They are intended to serve as a guide to help resolve those situations in an efficient, cost-effective, and customer-friendly manner. Service technicians should always protect customers' property so that the work area is as clean after the service call is completed as it was before the job was started. Protecting the work area with newspaper or builder's paper takes just a few minutes and can make the cleanup much easier. Anytime that a filter, fuel unit, or fuel line fitting is disassembled, drip pans or trays should be placed underneath to prevent fuel from staining or damaging floors and leaving an odor. Since customers typically don't see the work that has been performed, the quality of the work is often judged by the cleanliness of the work area at completion. After the job is finished and the work area is clean, take a minute to wipe down the heating equipment with a clean rag or cloth. Don't use oily rags for this purpose as they can leave an odor and possibly result in a callback. Before leaving the premises, let the customer know what was done and advise them of any recommendations to follow up work. When a clogged fuel line, filter, pump, or strainer is discovered, the following procedures are recommended. Examine the filter cartridge, canister, and the fuel assembly components for evidence of water. Whenever water is detected, it should be removed to the extent practical from the tank and properly disposed. Then, whenever possible, perform the following procedures. Disconnect the fuel line from the inlet of the filter. Connect a push-pull pump to the line and operate until clean fuel flows freely. Now, if the filter is located at the tank, you can skip this first step and then go on to number 2. Depending on the type of filter, either replace the filter element and gaskets and/or spin-on filter. Disconnect the fuel line from the fuel unit. Connect a push-pull pump to the line and operate until clean fuel flows freely. Clean or replace the pump strainer. Completely remove the existing fuel unit cover gasket and install the correct new gasket. Then reconnect the fuel line and bleed air from the fuel unit. Lastly, check the running vacuum. Compare the reading to the approximated calculated vacuum using the following formula: 1 inch for every foot of vertical lift, 1 inch for every 10 feet of horizontal run, 1 inch for the filter, and 2 to 4 inches for an OSV valve. If the reading exceeds the calculated vacuum, there may be a restriction in the line. Inspect the exposed line to see whether it has been damaged, kinked, or crushed. If a defect is found, replace the line. Never attempt to repair a damaged fuel line. If the line appears to be in good shape, try using a push-pull pump again and recheck running vacuum after you've cleared the obstruction. If the unit is part of a 2-pipe system, consider converting it to a 1-pipe system. Doing so will reduce the amount of fuel being filtered by over 90%, and it can reduce the need for filter replacement. When converting a fuel unit to a 1-pipe operation, consider installing a fuel deaerator. If a deaerator will not be used, be sure to remove the bypass plug if the fuel unit has one. For any installation that is operating on a 1-pipe system, if the filter needs replacement even more than twice a year, a more permanent remedy may warrant consideration. Filter clogging may be a symptom of bacteria in the fuel, which can cause microbiologically induced corrosion. If the sludge problem persists after the tank has been cleaned, the fuel should be tested and treated as needed. Options include initiating a design fuel treatment program and tank replacement. Let's look at some filter cartridges from the same job that demonstrate the effect of a comprehensive fuel treatment program. This one is typical of what was found after deliveries before a fuel treatment program was started. This one was replaced a few months later, and this one was replaced approximately a year later during a tune-up. When a customer's tank is empty, before it is scheduled for delivery, the following procedures are recommended. When an automatic delivery customer's tank is out of fuel, it is extremely important to determine why the tank is empty before making a delivery. First, the technician should measure the tank to determine that it is actually dry. Knocking on the side of the tank doesn't work. Get out the measuring stick and make sure. Once it is established that the tank is empty, office personnel should research when the tank was last filled and determine if it was currently due for delivery. If the tank was due for delivery, a service technician can deliver enough fuel to restore operation until a full delivery can be made. But if the tank is reported to have been recently filled or wasn't due for a delivery, additional research is required to determine: could a recent delivery have been made to a different tank or customer? Next, evaluate the last delivery data. Was the amount of fuel delivered less than anticipated? Is it possible that a short fill was made and not considered when calculating when more fuel would be required? The investigation should continue with a conversation with the customer to determine if there have been any changes which might have caused fuel consumption to increase. Changes such as a new baby. With a new baby in the home, the family often keeps the thermostat higher and uses more hot water, increasing their usage. Are there additional people living in the home? If more people have moved in, consumption will increase. Check to see if family members have returned from college or gotten married and moved home, or if parents or other people have moved into the household. Perhaps there was a change in lifestyle. If the family is spending more time at home, consumption will normally increase. Check to see if a family member who is working outside the home has recently retired or is now working from home. Perhaps it's home additions. People often don't realize that they'll consume more fuel when they build additions to their home. With additional heated living space, consumption will increase, and so-called energy savers, such as a new fireplace, can increase fuel consumption as well. It's a good practice to encourage service technicians and fuel drivers to notify the office when they notice work being performed at a customer's location. The office then can contact the customer and decide if it's appropriate to adjust their K-factor to avoid future runouts. Additional fuel-fired appliances, such as pool heaters, can increase fuel usage dramatically. If it's determined during the customer interview that there's a logical explanation for the increased consumption, the service technician should provide enough fuel to maintain heat until the delivery can be made. The customer's K-factor should also be adjusted to prevent future runouts. However, when a reason for the out-of-fuel call cannot be determined, consideration must be given to the possibility that the tank and/or fuel lines may be leaking. In that case, filling the tank can make an existing problem much worse. The situation must be thoroughly investigated to establish that the fuel storage system is sound. In cases where the customer requires more fuel to be delivered before the situation can be fully examined, a temporary tank should be employed or a minimal volume delivery made. It is important the customer then proceed with having the tank and fuel lines checked. In some cases, the oil heat supplier can check for a leaking fuel tank or lines. Let's take a look at the possibility of fuel line leaks and how to deal with them. Fuel line leaks can develop over time, especially in unprotected fuel lines that are buried in concrete or dirt. Sudden leaks also occur, often the result of activities that have nothing to do with the system, such as the building settling or contractors working on the property accidentally damaging the line. Workers who are landscaping, gardening, exterminating, installing underground sprinkler systems, or performing other activities may have damaged fuel lines without knowing it. Leaking suction lines do not always cause the burner to stop operating because they are sometimes operating on gravity or siphon flow and leaks go undetected. However, slight suction line leaks can lead to service problems, including rough starts, rough stops, noise, after dripped, etc. Unfortunately, leaking return lines cause no such problem, but they can cause serious environmental damage. Since leaking return lines do not affect burner performance, they can go undetected for a long period of time before being discovered. While suction lines can be checked for leaks by following the procedures we're going to outline next, return lines can't always be checked with confidence because they often terminate above the fuel level in the tank. This is another reason that NORA recommends the systems to be operating on one pipe whenever possible. If there is reason to suspect that a fuel line is leaking, here is what NORA recommends. First, perform a visual check to look for signs of fuel leaks along the path of the fuel line and at the filter. Next, verify the fuel unit holds vacuum by performing the following procedure. Disconnect the inlet line and fitting from the suction port of the fuel unit. Apply pipe joint compound to a vacuum gauge and install it into the suction port. If the unit is connected to a two-pipe system, remove the return line fitting and bypass plug. Apply pipe joint compound to a plug and install it into the return port. Turn on the burner and open the air bleeder. Close the bleeder when the vacuum reaches 15 inches and then turn off the burner. The vacuum should hold for 5 minutes. If it doesn't, repair or replace the fuel unit and perform the same test on the new or repaired unit. If the unit holds vacuum, remove the vacuum gauge, apply pipe joint compound to the inlet line fitting, reinstall it, and reconnect the suction line. This process verifies the fuel unit will hold vacuum. It is not leaking and is suitable for use for testing the fuel line. This procedure can then be used to check for a leak in the piping between an above-ground storage tank and the burner, or in the line between the burner and the shutoff where the line from an underground storage tank enters the building. Shut off the fuel valve at the tank or wall and disconnect the fuel line. Connect a plug to the disconnected fuel line and start the burner. Once the vacuum reaches 20 inches, turn off the burner. The vacuum should hold for 30 minutes. If it doesn't, there's a leak in the fuel line, filter, or fittings. Once you've double-checked the filters and valves to establish that they are not the cause of the leak, change the fuel line. When installing new copper fuel lines, be sure to use tubing that is polyethylene coated and/or sleeved in protected tubing if the line will contact dirt or concrete. Then perform the same test on the new line. If the line checks out, remove the plug, reconnect the line to the fuel tank and open the fuel valve. Be sure that all air has been bled out of the line. Then let the unit run through several cycles while you clean the work area and complete your paperwork. A vacuum test of the fuel line can also be performed using a hand vacuum pump, sometimes referred to as a push-pull pump. Since the check valve on these pumps often becomes weak over time, a ball valve should be threaded into the suction side check valve. If the hand pump does not have a vacuum gauge on it, install one in the flare fitting on the line at the tank. Then, instead of running the burner to generate vacuum, simply pull the handle of the pump until the desired vacuum is reached and close the ball valve to tightly close the line. If the vacuum holds for 30 minutes, the fuel line is not leaking. Now let's look at how to deal with cold temperature issues. As fuel is chilled below a certain temperature, it becomes cloudy due to the formation of wax crystals. These crystals affect the fuel's ability to flow through the lines, pass through the filter, and be fully atomized at the nozzle. As the fuel becomes even colder, it begins to gel, leading to what is commonly called frozen fuel lines. Free water trapped in fuel lines can also freeze and clog the fuel line. Outdoor above-ground storage tanks with fuel lines that are run from the bottom of the tank are most susceptible to these icing problems. It's much easier to prevent frozen lines than to treat them. There are several additives available, commonly referred to as cold flow improvers, that lower the temperature at which the fuel in the tank and lines freezes. Most of these products do a very good job of preventing waxing and gelling problems, but a far less effective job when added to a tank that already has a problem. Two good ways to dispense these products is to have them automatically dispensed with each delivery, or to manually add the proper dose to each tank before delivery. Simply pouring a dose into an already frozen tank and lines does not usually solve the problem. Another method of dealing with cold flow problems is to use straight kerosene or blend it with the fuel. Kerosene dissolves wax and flows better in very cold temperatures. As more and more underground storage tanks have been replaced with outdoor above-ground storage tanks, cold flow problems have become more common. Too many tanks have been installed outside without sufficient thought being given to the potential service problems. Outside tanks should be encased in enclosures, and exposed fuel lines should be insulated to protect them from the elements. When an outside tank does freeze, it is the service technician's job to get the system up and running so the rest of the house doesn't also freeze. Once the technician has determined the lines are frozen, the following procedures are recommended. Check the tank connection. If the fuel line is pulled off the bottom of the tank, reroute the line to pull through a tapping at the top and run the line at least 6 inches off the bottom. Be sure to fully close and plug the valve at the tank bottom. Never assume that the valve is closed. There have been instances of tanks thawing and draining through what someone believed to be a closed tank valve when the temperature is increased. Use a manual push-pull pump to be sure the line is clear all the way to the burner. Insulate the line from the tank to the location where it enters the building, and advise the customer about the advantages of tank enclosures and encourage them to add one. In addition to frozen lines, cold fuel causes other problems for the oil burners. Cold fuel doesn't atomize well, and as viscosity increases, more fuel flows through the nozzle. In areas where outside tanks are exposed to cold temperatures, it's advisable to consider installing a fuel deaerator to warm the fuel before it reaches the nozzle, to install a nozzle line heater to improve combustion, and inform the customer on the advantages of an inside tank or tank enclosure.